I hope you are doing good and fine. So, shall we begin? See, so what we have done in the morning session was that we have done certain things regarding energy. So, let me just revise that stuff. I told you that energy in any orbit of one electron species. Today, we will be doing all the questions for one electron species itself. So, En will be what? E1 upon n square. Are you getting it? Okay, now second one was that ionization energy is what? Minus of E1, if you remember that. I told you E1 was minus of 13.6 into Z square electron volt per atom. So if you understand that thing, can I say IE, ionization energy, will be equal to 13.6 into Z square electron volt per atom. Is that clear? Now, certain energies we need to learn. I have discussed earlier also. We'll need it today. Like, if you remember, orbit number 1, 2, 3, 4, 5, and so on till orbit number infinity. 1, 2, 3, 4, 5, 6. This will be minus of 13.6 if I'm talking about hydrogen atom, electron volt per atom. This will be minus of 3.4, minus of 1.51, minus of 0.85, minus of 0.34. All of them electron volt per atom. Remember that, all of them electron volt per atom. Now, see, I told you that difference between orbit number 2 and orbit number 1 is 10.2 electron volt in hydrogen atom specifically. This is all for hydrogen atom. This will be 1.89, this will be 0.66, and this will be 0.31 electron volt. You can see that the energy gap between the two successive orbits keeps on decreasing, and energy of orbit number infinity will be 0 electron volt. Now, I also told you few things. What was that? That E2 minus E1 is 10.2 electron volt. E3 minus E2 was 3.4 electron volt, and E4 minus E3 was how much? No, this was not. Sorry, my mistake. This is 1.89 electron volt, and this was 0.66 electron volt, and E5 minus E4. E5 minus E4 will be 0.31 electron volt. Now, beyond that, E3 minus E1, we have discussed this thing in the previous classes, was how much? 12.09 electron volt. E4 minus E1 is 12.75 electron volt, and E5 minus E4 will be 13.06 electron volt. Am I correct? No, this is incorrect. This should be 1. This should be 1. Yes or no? So we will be needing all these values today, and if you learn these values, you will see that how easy this chemistry, this chapter atomic structure becomes. Okay, so let's see that. Okay, now, acha, one more thing. Delta E, what is that? The energy difference between two orbits. This is N1, this is say N2. This delta E, I told you, this delta E is given by 13.6 into Z square into 1 upon N1 square minus 1 upon N2 square electron volt per atom. Please mind the units as well. Please mind the units. They are very, very important. Okay. So let's begin the questions. The question number 1 today in this evening session is, if I give you all these questions are pertaining to one electron species, what are those like? H, helium plus, lithium 2 plus, beryllium 3 plus, and so on, sodium 10 plus also, and so on. Okay, just keep one electron, remove other electrons as such. So I'm giving you ionization energy was given as 640 electron volt. They're saying energy of nth orbit is minus of 40 electron volt. They're saying find n. Find n. Come on, find n. Find n. But if you remember that, the relationship between En and n was what? It was En is equal to E1 upon n square. And what is E1? What is E1? If you take IE, E1 is what? E1 is minus of IE. That means E1 will be minus of how much? 640 electron volt. Are you getting that? So E1 I got as 640 electron volt. So if I put it over there, n square will be E1 upon En. So E1 is minus of 640 and En is minus of 40 electron volt. Minus minus cancels up. This will be 16. That means n square is equal to 16. That means n will be equal to 4. So we are talking about orbit number 4. In this particular, very good, bache, very good. In this particular atom or ion, we are talking about orbit number 4. Is that clear to all of you? Okay. Shall we move forward? You can note it down. Be quick. Note it down. Also, we should be aware of the first separation energy, second separation energy, first excitation energy, second excitation energy, all of these. Okay. So I'm giving you one more question, and this question says that ionization energy is given as 81 electron volt. Okay, in a 1 electron species, and the question says find second excitation, find second excitation energy. Come on, find second excitation energy. It's a good question. It's a good question. Try to do it. Give me the answers, please. It's a good question. Find second excitation energy. If somehow you people have missed what is second excitation energy, let me tell you. This is orbit number 1, this is orbit number 2, this is orbit number 3. The energy required to move electron from orbit number 1 to orbit number 3 is called second excitation energy. The energy required to move electron from orbit number 1 to orbit number 2 is called first excitation energy. For excitation energy, we have to move from orbit number 1. This is any 1 electron species where ionization energy is given as 81 electron volt. They're saying find second excitation energy. Come on, second excitation energy. How much energy will be required to move electron from orbit number 1 to orbit number 3? That's the question. And it cannot be -9 because you cannot give -9 electron volt energy. It will require certain thing which is positive in nature. If this electron has to jump, this will absorb a photon. Only then it will go there. So how much energy this photon should have so that it can go there? That's the question, basically. That's the question. Are you getting it? Are you getting it? So look up over here. What I'm saying is that if IE is 81 electron volt, from here can I say that E1 will be minus of 81 electron volt? Because E1 is equal to minus of IE. So that means this energy number 1 is how much? E1 is minus of 81 electron volt. So once you get E1, can you calculate this En? Or this is called E3. So E3 will be what? E1 upon n square. E1 is what? Minus of 81. N square means 3 square. Are you getting it? Sorry. Undo there. So this will be minus of 81 and this will become 9 equal to minus of 9 electron volt. That actually means this E3 is how much? Minus of 9 electron volt. Minus of 9 electron volt. And if I plot the diagram again, see this thing? This is orbit number 1, this is orbit number 3, this is minus of 81 electron volt and this is minus of 9 electron volt. The difference between these two, delta E, is the amount of energy required. Yes or no? So this delta E will be what? I told you, higher minus lower. Higher minus lower. How much? Minus of 9 minus of minus 81. That is minus 9 plus 81 equal to 72 electron volt. It's a good question. You will require, the gap is how much? 72 electron volt. 72 electron volt. This much of energy will be required if you want to send this electron from orbit number 1 to orbit number 3. Is that clear, beta, everyone? Are you all getting that? First calculate E1. E1 will be minus of 81 electron volt. Then find out E3 because second excitation energy is the energy required to move electron from orbit number 1 to orbit number 3. How much energy is required? I'm not asking the energy of orbit number 3 or second excited state. I'm not asking that. That will be minus 9. I'm asking amount of energy required. That will be the gap, delta E. Is that clear to all of you? All of you? Come on. Okay. Okay. Good. Very good. Now see this thing. I told you that I'm giving you a question. All these questions are for single electron species. Okay. So I'm giving you Z is given as 5, N1 is given as 3, N2 is given as 4. They're asking find delta E. Find delta E. The energy difference between orbit number 3 and orbit number 4 when Z is given as 5. Very simple one. How you'll do it? We all know that delta E is equal to 13.6 into Z square 1 upon N1 square minus 1 upon N2 square. Yes or no? So can you put over there 13.6 into Z square? That will be 25 into 1 upon N1 square. That means 3 square minus 1 upon 4 square. That will be 13.6 into 25, and this will be into how much? 1 upon 9 minus 1 upon 16. So can I take LCM? Can I take LCM? And it will be 13.6 into 25. 16 minus 9 will be 7, and this will be 9 into 16. 9 into 16. Boys, I mean, understand, this will be 175. This will be 144. So 175 upon 144 will be just more than 1. Just more than 1. Yes or no? That means overall this value will be more than 13.6. Just more than 13.6. Yes or no? Don't try to calculate exact answer, because in these kind of questions, the options are very far apart. So the correct answer is actually 16.5 electron volt. Even if your answer is coming like 17, 17.5, maybe 18 also, it's okay. The options are quite far apart. Don't worry about these things. Sure about it? You should be worrying about the exact calculations only when the options are very close. Options are very close. Yes or no? Okay? Okay, good. Very good. Very good. Now come over here. I mean, you people know that potential energy is equal to what? Equal to minus of 2 into kinetic energy, and also potential energy is equal to 2 into total energy. Also, kinetic energy is equal to minus of En. Remember that or not? You will need this data in the coming question. Shall I do it? Or shall I give it to you? The question is that in any one electron species, potential energy is given as minus of 1.08 electron volt. Not one electron, I'm giving you not one electron. We can take it hydrogen. We can take it hydrogen, in any hydrogen atom. Potential energy is given as minus of 1.08 electron volt. Minus of 1.08 electron volt. They're saying find orbit number. Which orbit we are talking about? Which orbit we are talking about? Come on. Which orbit we are talking about? Be very clear. Potential energy is given as minus of 1.08 electron volt. Minus of 1.08 electron volt. LC sir fan? No, it is not correct. What kind of fan you are? I mean, give me correct answer. Ashwak is correct. What is this number? I mean, I do not know. 11763. This is also correct. Correct. The correct answer is orbit number 5. And how you know that? I told you this thing, that potential energy is equal to 2 into total energy. That means total energy will be potential energy divided by 2. Minus of 1.08 divided by 2 will be minus of 0.54 electron volt. Now I told you to learn certain values. Remember that? In hydrogen atom, learn certain values. This energy belongs to orbit number 5. Yes. So this N must be 5. N must be 5. Remember that this is minus of 13.6, minus of 3.4, minus of 1.51, minus of 0.85, and minus of 0.54. So minus of 0.5 belongs to 1, 2, 3, 4, and 5th orbit. Learn, but you please learn. When you learn these values, trust me, you will become champions of atomic structure. There is nothing which you cannot handle that. Otherwise, it will take a lot of time to handle. Okay? Shall we go further? Shall we move? Okay? Chalo, theek hai. Okay, here we go. So let's have one more question, bachcho, hai na? This question also requires the knowledge of certain things, values I have given to you. So let's see that. So what I'm saying is that this is N1 and this is say N2, anything. Or I can say, like say this is orbit number 1, this is any orbit number N. This is for hydrogen atom. This is for hydrogen atom I'm talking about. I'm talking about hydrogen atom. The electron was here. Electron was here. It absorbed a photon of 13.06 electron volt. It absorbed a photon of 13.06 electron volt. It will go up. It will go up. When it will come down. When it will come down, it can come down in n number of ways. It can come down in n number of ways. Yes or no? Find total number of lines. Total number of lines formed when electron comes from orbit number n to orbit number 1. Find total number of lines formed. Come on. If this photon is having energy of 13.06 electron volt, how many total number of lines will be formed? Ashfaq, you are doing supremely good. Very good, Ashfaq. Very, very good. Electron is in orbit number 1. If it gains the energy from a photon of 13.06 electron volt, it will go up. And my question that when it goes up, it will come down. It can come down in n number of ways. So find total number of lines formed. Yes, Manu, very good. Very good, Manu. Surya, no, no, no. So first of all, one should understand that in hydrogen atom, this energy gap is between what? It is basically, if you remember, E5 minus E1 is equal to 13.06 electron volt. Remember that or not? I gave you all these values. Yes, E5 minus E1. Very good, Ashfaq. Very, very good. So E5 minus E1. That means this photon will absorb this much energy and will go where? To orbit number 5. So this end should be what? 5. This is orbit number 5. Yes or no? And when the electron will come down, the total lines formed will be n into n minus 1 upon 2. So 5 into 4 by 2 will be equal to 10 lines. So total number of lines will be 10. Total number of lines will be 10. Yes or no? And I mean, if they ask you further that number of Lyman lines, how many? I told you it was n minus 1 equal to what? 5 minus 1 equal to 5 minus 1. How many? 4. Yes or no? Very good. Balmer lines. Balmer lines will be just 1 less than 3. Then Paschen lines. Paschen lines will be again 1 less, 2. Yes or no? And then bracket. Bracket lines will be 1. That's it. Add them all, you will get 10. 4, 3, 7, 7, 2, 9 and 1, 10. So total 10 lines are formed. They can ask you anything. Anything. Okay? Is that clear? Just learn these values. I gave you these values. E5 minus E1 is 13.06. E4 minus E1 is 12.75 electron volt. And E3 minus E1 is 12.09 electron volt. And E2 minus E1 is 10.2 electron volt. Please learn these values. Come whatever, keep learning. Once you learn these values, you become the champions of atomic structure. So can I move ahead? Chalo aa jao. One more question again, for the sake of practice. Orbit number 1, orbit number n, and electron was here, and now it absorbs a photon of energy 12.09 electron volt. 12.09 electron volt. It will go up. When it will come down, it can come down in n number of ways. I'm saying total lines formed. Now total lines formed. So this gap, one should remember, when you see this gap, understand this is what? The gap between what? Which orbit? E3 minus E1. Yes or no? E3 minus E1 is equal to 12.09 electron volt. That means this n should be equal to 3. Now from 3 to 1, total lines formed will be how many? N into n minus 1 upon 2 equal to 3 into 2 by 2 will be equal to 3 lines. So total lines will be 3. And if someone asks you, among these 3 lines, how many Lyman lines will be there? How many Lyman lines? Come on. Will be equal to n minus 1, 3 minus 1 equal to 2, and one Balmer line will be there. One Balmer line will be there, and that will be just one less than. This will be, total will be 3. So 2 Lyman lines and 1 Balmer line. Acha, who will tell me what will be the color of this Balmer line? The color of this Balmer line. Who will tell me? Come on. Color of this Balmer line. Come on, Gautam. Come on. Bolo yaar. See this thing. See this thing. 1, 2, and 3. So orbit number 1, 2, and 3. This is the Lyman line. This is the Lyman line. Now, from 3 to 2, only one will be formed. This is the first line. This is the only line. That is the first line. First line is red line. It is the red line. Are you getting it? It is the red line. And suppose in the Balmer series, I'm saying that this is the first line, orbit number 1, 2, 3, 4, 5, 6. First line, second line, third line, and fourth line. Only 4 lines are colored in hydrogen atom in Balmer series. Rest are what? Rest are in ultraviolet region. This is what? Red. This is what? Bolo? Blue. This is what? Blue, violet. This is what? Violet. Rest all are in ultraviolet region. Yes or no? Okay, come on. Let's do more questions. So this question says that delta E is given as 47.3 electron volt. N1 is given as 2. N2 is given as 3. They're saying find Z. Find Z. All these questions are belonging to one electron species. Come on, handle that. Come on. Do it. Try to get an approximate answer, है ना? Don't worry about the exact answer. Okay, let's do that. Simple one. So delta E is equal to 13.6 into Z square 1 upon N1 square minus 1 upon N2 square. Okay? Okay. So delta E is given as 47.3 equal to 13.6 into Z square. That will become 1 upon 4 minus 1 upon 9. Agree or not? So 47.3 equal to 13.6 into Z square. This will be 5 upon 36. 5 upon 36. So can I say, if you guys allow me, that Z square will be 47.3 into 36 divided by 13.6 into 5. Will you agree? Rohita, ये कौन सा आंसर है? What kind of this? See, so I mean, if you allow me a little bit of approximation, I believe I can write that down. I mean, can I make it 50? Please, yaar, allow me to make it 50, yaar. I do not know this 47 point something. किस में आएगा? Can I? 50. Okay. Can I make it 35? करने दो यार. Can I make it 14? And can I make it 5? चलेगा? 5, 7, 7, 2, 2, 25. So Z square will be 25. Z is equal to 5. Yes or no? Even if you are getting the answer, sir, I am getting 4.8. Don't worry. Z cannot be in decimal. Z cannot be fractional. So go to the nearest possible integer. So nearest possible integer is how much? 5. Even if you are getting 4.7, 5, 5.1, 5, 5.2 equal to 5. Anything you get, the answer will be 5 itself. Z will be an integer, a positive integer. Yes or no? Yes or no? Please master this concept of approximation. You will do very good. Okay? One concept is remaining, and that is basically Ashfaq 4 is not. It will be 5. Okay. Okay. Trishal, I mean, you want me to explain that again? Explain it again. Okay. So, I mean, you know this formula? I believe you have joined late. That's why you are saying that. Okay, got it. I mean, so don't worry at all. You try at home, and if there is any problem you come across, you can tell me. You should be very well versed with this formula, na? First of all, that is the delta E. So once you know the formulas, you will be able to handle those things. Okay? Can I continue? This topic, the coming topic, velocity, you will understand properly. See that. So there is one more topic left. I mean, velocity. What is velocity or the speed of electron? Velocity or speed of electron? Speed of electron. I mean, this V is given as 2 pi k ze square upon nh. Remember that this V is proportional to what? Z, but this V is proportional to what? 1 upon n. Rest all are constant. Rest all are constant. So can I say from here that V will be proportional to Z by n? Z by n. Also, I mean, if I go with the value, this V will be equal to 2.18 into 10 to power of 6 into Z by n. Meter per second. Very, very important. I mean, if you think that this velocity is almost 100 times less than the speed of light. Almost 100 times less than speed of light. Getting it? Z by n. Okay. So V is proportional to Z by n. I want you guys to focus that when I was telling you about energy and radius, the radius and energy, they both depended on mass. But over here, for the very first time, we are having an expression of V which does not depend on mass. That means even if the mass of electron changes, the velocity of electron will not change. The speed of electron will not change. So please, can you write down this velocity of electron is independent of mass of electron. Very, very important. Very, very important, bacho. Are you getting it? Over here, there is nothing like mass out here. While in radius, I taught you that radius was what? Come on. It was n square h square upon 4 pi square m k ze square. So m is here for radius. With respect to energy, it was like say minus of 2 pi square m k square z square e to the power of 4 upon n square h square. Here also m is there. But with velocity, if you remember, it is like say 2 pi k ze square upon nh. There is no mass out here. So these two things depend on mass of electron. Yes or no? But this does not depend on mass at all. Yes or no? This is inversely proportional to mass. This is directly proportional to mass. So any subtle question if they ask you, any good question they ask you, you should be prepared for that. So I'm taking you back towards the velocity. Z by n. Okay? Keep looking there. So my question is that find, or you can say compare V1 of hydrogen, V1 of helium plus and V1 of lithium 2 plus. In which case the electron will have higher velocity. Come on. Orbit number 1 is there in everyone. So you know that velocity will be proportional to Z because n is same. N is 1. Orbit number is 1. Trishal, orbit number is 1. Are you getting that? So n will be same. So V is proportional to Z. More the Z, more will be what? The velocity. So if I go with the ratio will be like say 1 is to 2 is to 3. Are you getting it? So velocity of hydrogen, electron in hydrogen atom will be 1. In that case, velocity of electron in He plus, helium plus will be 2. Okay? And this will be 3. So this will be more. Okay, now tell you one thing. One more question. Find ratio of velocity of electron like say V1H, V2H, V3H. Come on. Here basically you can see that we are talking about hydrogen atom only. That means Z is same. That means V is proportional to 1 by N. V is proportional to 1 by N. That means if I take the ratio, this will be 1 by 1 is to 1 by 2 is to 1 by 3. That means, that actually means it will be taking the LCM multiply by 6. 6 is to 3 is to 2. That means if velocity of hydrogen electron in hydrogen atom is say in first orbit is say 6 meter per second, in that case it will be 3 meter per second, this will be 2 meter per second. That means closer the electron, faster the speed. Closer the electron, faster the speed. Will you all agree? Will you all agree? Acha, who will tell me what will be the speed of electron in the infinite orbit? Orbit number infinity. The velocity of electron in the orbit number infinity. See over there, when you say infinity, V proportional to 1 by infinity, it will be 0. That means in the outermost orbit, that is the infinite orbit, electron does not move at all. Hello? Electron does not move at all. That electron is called unbounded state or free state. Okay? Okay. Now, one more question, bacho. A very, very important question. Please, frequency of revolution of electron in any one electron species is proportional to Z square upon N cube. True or false? True or false? That's the question. True or false? Frequency of revolution of electron in any species is proportional to Z square by N cube. This is true or false? So to solve this, we need to understand that frequency is actually 1 upon time period. Time taken by electron to complete one revolution. So if you look over there, I also know what is time period. The distance traveled, how much? The circumference. This is a nucleus. The distance traveled by the electron in one orbit will be, this will be 2 pi r, the circumference, divided by the velocity. Distance upon velocity will give you what? Time. Agree or not? So if you agree with me, T will be proportional to R upon V. Yes or no? And I also know that R is proportional to N square. Hello, beta. R is proportional to N square. And V is proportional to, sorry, my mistake. N square by Z. And V is proportional to Z by N. Yes or no? Yes or no? So once you agree with that stuff, I can very well say that T will be proportional to, instead of R, I can put this thing, N square by Z. N square by Z. And instead of V, I can put what? Z by N. Z by N. It goes up. So T is proportional to N cube by Z square. Yes or no? So once you understand that, very good, Gautam, very good. So I know that frequency is inversely proportional to T. That means frequency will be inversely proportional to, instead of T, put what? Put what? N cube and Z square will go up. So that means this statement was true. It was true. Yes or no? Good, bachu. Very good. Keep it up. Keep it up. Can I move forward? Done. Okay. One more question is there. Force of nucleus on electron is proportional to, we can say, z cube by n to the power of 4. True or false? Z cube upon n to the power of 4. Let's see that. So, I mean, if you see that what I'm saying, I told you that this is the nucleus and this is the electron which is trying to revolve. This centripetal force will be equal to centrifugal force. So, this was given as what? If you remember, K ZE square. This is what? Plus ZE, and this is what? E. K ZE square upon R square equal to what? MV square upon R. Yes or no? This is centripetal force, the Coulombic force of attraction, and that is what? Centrifugal force. You can take any one of them. You can take any one of them. I'm taking this thing. I'm taking this thing. Yes or no? So what I'm saying is that this force F is proportional to V square upon R. V square upon R. And I know one thing, that V is proportional to what? Z by N. And R is proportional to what? N square by Z. N square by Z. So F will be proportional to V square will be Z square upon N square. And R will be N square upon Z. Yes or no? Z will go up. So F is proportional to Z cube upon N to the power of 4. Yes, it is also true. This was also true or false. The answer is true. Yes or no? Good. Very good. So these are two good questions. I mean, they can ask you. Note them down. Note them down. Just revise and practice. There is nothing in that once you practice that. Done? Okay. So it's a question. It says for hydrogen atom, this is orbit number 3. This is, say, orbit number 1. No, this is not orbit number 3. They have not given anything. They have just given N1 and N2. They're given that. They're saying the difference between the potential energy of orbit number N1 and orbit number N2. Difference, the delta P is given as 24.18 electron volt. They're saying find delta E. Find delta E. Come on. Delta PE is given as 20. Sorry, this is minus of 24 point, or you can say one thing. Keep it 24 because delta is always higher minus lower. Delta is always higher minus lower. Keep it 24.18. Find delta E. Find delta E. Gautam is correct. Gautam, 1920 you are saying is correct. Keep your names, boys and girls, I mean, so that I can at least pronounce it. I do not know what is 1920. Sai, it is not correct, beta. Sai, check it out. See, if you remember, I told you that potential energy is twice of total energy. Are you getting it? That means delta PE will also be twice of delta En. Or I can say delta En will be delta PE by 2. Delta PE is what? 24.18 divided by 2. This will be delta En will be 12.09 electron volt. Yes or no? If it is 12.09 electron volt, but so can you tell me which orbits I'm talking about? Which orbits I'm talking about in hydrogen atom? They can also ask you the orbit number. No, Surya, no, please be careful. I have told you certain things, but please be careful. Yes. Yes, yes. But remember that, please remember, bacho, this is very, very important that you are not doing any blunder out here. That E2 minus E1 I gave you was 10.2 electron volt. E3 minus E1 I gave you was 12.09 electron volt. The moment you see this value, beta, please, there should be a bulb jalna chahiye yaar dimag mein, hai na, chamakna chahiye. This will be like, say what? This will be orbit number 1, this will be orbit number 3. There is no chance that the difference of 12.09 electron volt is occurring in any other two orbits. Okay? Okay? Okay. Can I? Okay, now see this part. See this part. This is very, very important. Which transition in emission spectrum, which transition in emission spectrum in hydrogen atom will have maximum frequency, okay? Okay, so I'm giving you first option 1 to 10, second 2 to 7, third 2 to 1, fourth 3 to 2. Come on. Which transition and emission spectrum in hydrogen atom will have maximum frequency? Maximum frequency. Okay. Okay. Be careful, don't do any blunder. Just don't do any blunder, rest is okay. Rest is okay, okay? Okay? Be careful. Acha. The keyword here is emission spectrum. Emission spectrum means the electron should come from higher to lower orbit. Higher to lower orbit. Over here it is going from lower to higher orbit. No, this is not the case of emission spectrum. This is also not the case of emission spectrum. So clearly these two cannot be the answer. And the reason being, they both belong to what? Absorption spectrum. Absorption spectrum. Are you getting that? Are you getting that? Also, now come the very, very important point. You know that delta E is equal to what? H nu. That means delta E, if it is higher, frequency will also be higher. Yes or no? So for frequency to be higher, delta E should be higher. Now I have told you multiple times that orbit number 1, orbit number 2, orbit number 3, orbit number 4, orbit number 5. 1, 2, 3, 4, 5. This difference is how much? Delta E is how much? 10.2 electron volt from 2 to 1. This is what? How much? 1.89. This is 0.66. This is 0.31. Yes or no? So you can see that clearly when the electron jumps from 2 to 1, the difference of energy is maximum. It is almost 5 times than this thing. I have done a question. Remember that? बच्चों भूल जाते हो आप लोग that frequency maximum in Lyman upon frequency maximum, like say frequency, this was frequency minimum in and frequency in Balmer. This was like say 10.2 upon 1.89, approximately 5.4. Remember that or not? Frequency minimum and frequency minimum here. Are you getting it? So it is almost 5 times. So answer will be third. Yes or no? Yes or no? First of all, understand what they're asking for. They're asking for absorption or for emission. Sure about it? Okay. Okay, now let's see one more question. In which transition lambda maximum will be there? In which transition you will get lambda maximum? Okay, first option is like say from 10 to 1, second is say 7 to 1, and third one I am saying is say 4 to 3, and fourth I'm saying is say from 3 to 2. Come on, 3 to 2. Which case you believe you will have lambda maximum? Lambda maximum actually means delta E should be minimum. Also understand, if orbit number 1 is involved, understand 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this gap is way higher. This also is quite high, very, very high. They both are more than 10.2, agree or not? Because this gap is 10.2, that means this gap should be certainly more than 10.2. Yes or no? Okay, now coming to 4 to 3. 4 to 3, I told you what? This gap is how much? 0.66. Yes or no? And 3 to 2, this gap is 1.89. Yes or no? So the Lyman series have UV region and Balmer series visible region, so energy more in Lyman. Yes, correct. So Lyman will have more frequency, no doubt. Surya, correct, Surya. So least energy difference is here. Least the energy delta E minimum. So lambda will be maximum. Where? From 4 to 3. Yes or no? Are you getting that? 4 to 3. Can I, Bacho? A very good question coming up. Okay, see that this is for hydrogen atom, hai? So like this is N1, this is N2, and electron is jumping from here to here, and in the process a photon will be given off. And for this photon they are saying that the lambda given is 6569 angstrom. 6569 angstrom. They're saying this lambda belongs to which transition? First option, it's like say 2 to 1. Second is like say 4 to 3. Third option is from 4 to 2, and fourth option they are giving you is 3 to 2. Come on, which transition this process belongs to? Okay, Gautam is saying something. I mean, he's at least using a common sense. He is using a common sense. Very, very important, bacho. Very, very important. Very, very important. But so all these are like say applications of what we have learned earlier, na? Okay, one thing. But your observation is very important, bacho. Your observation is extremely important. Your observation is extremely important, bacho. Okay. So I told you something, and it was what? If this is, say, visible region, yes or no? That means it should be between 4,000 angstrom to 7500 angstrom. This wavelength is over here, 6569 angstrom. That means it lies in visible region. This lies in visible region, yes or no? If this lies in visible region perfectly, this cannot be the answer, this cannot be the answer. Now only two options are left, 4 to 2 or 3 to 2. So there are two options left now. Playing the game. So which option you will mark? Which option you will mark? It's so simple, bacho. So simple. We have done these questions in photoelectric effect. So very, very important. When delta E is in electron volt, yes or no, and lambda is in angstrom, 12400 upon lambda, you will get it. Yes or no? This must be in electron volt. This will be in angstrom. Agree or not? So once you agree with that, I believe delta E will be 12400 upon 6569. 6569. Yes or no? And if I say approximately, it will be 12400, and this will be like, say, 6. Even if I say 6,000, this is gone. This will be almost like, say, what, 2.1 kind of thing. Yes or no, boys? 2.1 approximately. Yes or no? So the delta E, which is approximately 2 kind of thing, is where? In hydrogen spectrum. The nearest value is 1.89. Nearest value is 1.89. Yes or no? 1.89. And if I say that, you will calculate it particularly, you will get this value as delta E is equal to 1.89 exactly electron volt. And this gap is for what? For which orbits? This is basically E3 minus E2. If you remember, 1.89 electron volt. This transition is for 3 to 2. Is for 3 to 2. Boys and girls, what are you doing? 3 to 2. And if I ask which color they are talking about, they're talking about which color? Come on, the first line. First line, boys. 1, 2, 3, 4, 5, 6. So this will be the first line, second line, third line, fourth line in the Balmer series. This will be red. This will be blue. Blue, violet, and blue. Oh, violet. Yes or no? This must be the red line. They're talking about actually something, some shade of red color. Some shade of red color. Is that okay? Is that okay? So these are some good quality questions. You just need to revise it, bacho. Just revise it. So what we are coming to the last question of the day. So let's see the question. Okay, this question says that we are having hydrogen atom again, orbit number 1 over here, and electron is here. A photon is coming of, say, 9.8 electron volt. How much? 9.8 electron volt. When this electron will absorb this 9.8 electron volt, it will go up. My question is that how many total lines will be formed when the electron returns? How many total spectral lines will be formed when the electron returns? Ashwak, correct? iPhone 13 Pro, no. Sai, no. See, boys, I mean, this is so simple. So simple. See, I told you in hydrogen atom, orbit number 1, orbit number 2, orbit number 3, orbit number 4. 1, 2, 3, 4. The minimum energy required to go to orbit number 2 is 10.2 electron volt. And over here, electron is getting how much? Only 9.8 electron volt. Yes or no? The minimum energy required to go to second is 10.2. It is not even having 10.2 also. That means this electron will not go to orbit number 2 also. That means this electron will not absorb this photon at all. This photon will simply pass by. It will not absorb. The electron will absorb only the energies which are in this zone. Yes or no? Is that clear? Is that clear? So there will be no spectral line. Answer will be no spectral line will be formed. No spectral line will be formed. Achha, if in this question, if I say, in the same question, if I say that instead of 9.8, I'm saying that 14 electron volt photon is coming, the energy of 14 electron volt. Now what will happen? What will happen? A photon of 14 electron volt is coming in hydrogen atom. The electron is in ground state. What will happen to it? Come on. Fifth excited state, 14 electron volt. Are you sure about it? Are you sure about it? Fourth, it will go to fourth orbit. From it is 14 electron volt. 14 electron volt. 6. क्या बोल रहे तुम लोग? We're speaking. See that. This is orbit number 1. This is minus of 13.6 electron volt. This is orbit number infinity. The energy is 0 electron volt. So once this electron absorbs a photon of 14 electron volt, the ionization energy is how much? 13.6 electron volt. How much energy I should add over here so that it becomes 0? 13.6 electron volt. It is coming with energy of 14 electron volt. That means this electron will first use 13.6 electron volt to reach to orbit number infinity, and from here it will run away with the kinetic energy of how much? 0.4 electron volt. This electron will fly away beyond infinity. It will move. It will be ejected completely with a speed of kinetic energy of 0.4 electron volt. Yes or no? Are you getting it? Getting that? Sure. So that will be your syllabus basically in the coming test. Please revise it, bachcho. Please revise it. It's extremely important. Okay. I wish you all the best. Thanks for your support, your love. Keep showering that. Bye, bachcho. Bye, all of you. Take care. Okay. Sharing is required. Sharing. Bye, bachcho. Bye. Good night to all of you.